Okay, so our previous video was about verifying that something was a solution to a differential equation. So if you're given a differential equation and they give you a potential solution, you can find out whether or not it's a solution, but at the moment we don't really have any tools for actually solving them. And this whole video is about that. In some sense, there's what I consider to be a pretty straightforward four-step process for solving differential equations, rather for solving separable differential equations. Solving differential equations in general is actually a really, really complicated field, an awesome field of mathematics. For this class, all you have to deal with is separable differential equations. And what it means to be separable is basically that you're going to be able to get all of the x terms on one side of the equation and all of the y terms on the other side of the equation. And once you've got, all of your x terms on one side and all of your y terms on the other side, we can basically integrate both sides and find out what the solution is. This will be a lot more clear as we get into an example. So let me go through those four steps. So, and you can pause, you can write this down. I don't know that I need to read these out loud. I'm going to go through all of them in the example that we get to right here. But the short of it is, you'll write y prime as dy dx. You'll multiply both sides by dx. Then you'll separate the variables, which just means get all the y terms, get all the dy's to one side, get all the x's and the dx's to the other side, and then you'll take the antiderivative of both sides, and you pretty much win. So if you've got those steps written down in your notes, keep going. I'm going to do one example with you, and then I'll give you one that you can sort of try on your own. So I want to find the general solution to the differential equation y prime over 2x minus 5 equals y squared. Earlier in the lesson we said that we wanted step 1 to be where we rewrite y prime as dy dx. So I'll simply write dy dx over 2x minus 5 equals y squared. Step 2 was when we said that we wanted to multiply both sides by the denominator. So we multiply both sides by dx. The whole point of that is to separate variables. I want to get all the x's on one side and all the y's on the other side. So doing that on the left causes the dx's to cancel out, and I'm left with dy over 2x minus 5 equals y squared dx. Now step 3 is where we actually start doing the separating, right? So since this side is the dy side, the y side, and this side is the dx side or the x side, the y squared needs to move over, and the 2x minus 5 needs to move over. To do that, I'll divide by y squared, and I'll multiply by 2x minus 5. I'm skipping some steps here, so make sure that it's clear to you what I'm doing. In fact, the first time I made this video, I made a mistake here and was not careful. So take care when you do that. Now that you've separated, like yay, there you've got all the y's on this side, you've got all the x's on this side, step 4 is where we actually take the antiderivative. So we'll say, all right, I've got them separated. I'll do the integral of dy over y squared here, and I'll do the integral of 2x minus 5 dx over here. On the left side, if you think of this as y to the negative 2, you'll up the power by 1 and divide by that new power. You'll basically end up with negative 1 over y equals, and this integral on this side is x squared minus 5x plus c. And as far as I'm concerned, this is a solution. Like, that's good. This is the general solution. Some people want to solve for y. It's not necessary unless it's multiple choice, or if the problem says, find the general solution, y is a function of x. If they do that, you kind of just have to jump through some hoops. In case you want to see it here, you'd multiply the negative over, get negative x squared plus 5x plus c. Technically, I suppose that should be a minus c, but because this is just a constant, it doesn't really matter if it's positive or negative. And then this is really tricky. You now have to do the reciprocal of both sides. But that does not mean that you can do 1 over x squared and 1 over 5x and 1 over c. In fact, that's really, really wrong. If you're going to reciprocal both sides, you have to literally take the reciprocal of the right side, which means you write 1 over negative x squared plus 5x plus c. This is the other way you could write this general solution. If the problem asked for a particular solution, they would have to have given you a point. If they had said find the particular solution passing through 1 comma negative 2, well then you'd plug in negative 2 for y, you plug in 1 for x, and solve for c, and you'd have your particular solution. I'm not going to do that in this problem because you'll get a chance to see that in the next example, the last example that I have in this lesson. So the last problem that I have, the last example, is I now do want us to find that particular solution. And remember, particular solution basically means, we're going to need to find c at the end, right? So we want to find the particular solution to the differential equation given below, passing through 2 comma 9. I really would highly recommend that you try this problem on your own. And you might want to do it in steps, like do step 1 and then unpause my video and watch it. Then do step 2 and unpause it. And do step 3 and unpause it. Like, step through it and make sure that you've got this. So here we go. Step 1, we rewrite dy dx instead of y prime. Right? So this was step 1. So now again, if you're doing this legitimately, pause the video, do step 2 on your own. Step 2 is really easy. All you have to do is multiply the dx over. That was step 2. Now again, if you're doing this on your own, pause it, do step 3. Step 3 is supposed to be where we separate, right? So this is the dx side, this is the dy side. So the only thing misplaced is the square root of y. So I'm going to effectively divide the square root of y to both sides. This ends up giving me dy over root y equals x dx. This was step 3. Because now this is the y side, it's all y. This is the x side, it's all x. Now that I've done that, we will go on and do step 4. Again, if you're doing this at home, pause the video, try it on your own. Step 4 is the one where we take the antiderivative of both sides. Okay. Now the right side is really easy. We can tell that's 1/2 x squared plus c. On the left side, you may want to rewrite that. You may want to write that as y to the negative 1/2 dy. Note that on the right side, I don't write the integral symbol anymore because we took the integral. On the left side, I am still writing the integral symbol because I haven't yet taken that integral. I really, really want you guys to practice using that notation and being careful with it. So when we do an antiderivative, we increase the power by 1. That becomes y to the 1/2 times the reciprocal of that, so times 2 equals, and we have our 1/2 x squared plus c. Right? So yay, this is my general solution. My general solution is 2 root y equals 1/2 x squared plus c. This thing here is my general solution. That's where we stopped on the previous problem. To find the particular solution, we need to go one step further than this. We need to solve for c. Solve for c using the point 2 comma 9. So I have 2 root 9 equals 1/2 2 squared plus c. 6 equals 2 plus c. That means c is 4. And so my particular solution is the same function I had up above, 2 root y equals 1/2 x squared. The difference is now it's plus 4. That's the particular solution. Now, just like I said in the previous video, if you wanted to, you could rewrite this. We could multiply both sides by 2 and get x squared plus 8 and then square both sides. This answer is also acceptable. I'm fine with either one of them. That's all I have in this video. We just have one left, and I'm hoping I can keep it on the short side. So wish us all luck.